morning, everyone. So we'll start with the procedure to draw Mohr circle. So Mohr circle is a easier way of understanding the compound stresses. In fact, even I could understand the importance of the compound stresses using Mohr circle. And as engineers, we are supposed to know how a material fails. And most of the cases, I think any material would have different types of forces acting on it. It may be compressive, tensile in X direction, and also you may have shear stresses in the other directions. So you may have several types of loads coming on the member. So we will try to understand how this could be solved through Mohr circle. Okay, now let us imagine maybe in a member you have a small element which has got forces which are acting in X direction and Y direction like this. I think it may be surprising for anybody to see why I am drawing this cuboid, this cubes like this or squares like this, and trying to show them as elements which are actually loaded. But in practical, you don't see anything like this. I'm not actually saying that you will have any components like this. I think anything that we have, maybe you have something like a cylinder, maybe something like a cylinder like this. Okay, something like a cylinder like this. When you have internal pressure, the cylinder wants to expand. So you will have some sort of a tensile stresses like this. The cylinder just doesn't want to expand like this, it also wants to expand in this direction. Expansion in this direction is called as lateral expansion. Expansion in this direction is called as longitudinal expansion. So you can definitely say, if you actually take a piece of the metal on the cylinder on the surface, the metal would experience the force like this and force like this. Okay, you can call this as X, you can call this as Y, whatever. In this way, I am actually trying to select a small element in the whole component. So I am showing it as X and Y. You don't see any components like cuboids in this. Okay. So let us say that this is equal to 100 MPa or 100 Newton per meter square. This is equal to 14 Newton per meter square. Okay. Now let us see. How do we see? Okay, how do we find? How do we use the Mohr circle to draw this? Okay. Now let us draw a horizontal line. Now this horizontal line will indicate the normal stresses. These indicate the normal stresses which is positive, which means it is tensile. These on the left hand side indicate the compressive stresses which are negative. If it is actually compressive, you put this on the negative side. If it is tensile, you put this on the positive side. Then you draw a vertical line like this. This is positive shear stress, this is negative shear stress. Here for this element you see that on both x-axis and y-axis, both are actually positive. And in your book, how do you do it? First you will have to roughly understand which side this diagram may appear. Since both are positive, the diagram will appear like this. Suppose if this is negative, then the diagram also can appear like this. So you need to leave more space on this side. Okay? So you can plan that way. Right now, anyway, I have made space for both. Okay? After making such a y-axis and x-axis like this, usually what students do is, they measure 1 centimeter each like this, and they do it. 1 centimeter like this, and do it. Okay? Here 100 centimeters means it would be equal to 10 centimeters. I don't know why. For a minute, I have some water and come. Range actually 10 centimeters in your book. So can you actually draw a line which is actually 10 centimeters? If it is possible, you please do it. Okay? So 1, 2, 3, 4, 5. So you can manage, otherwise I'll have to redo this for me. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So marked actually 10 here. In the examination, in the answer booklet, the first two sheets are actually the graph sheet and the semi-log sheet. People also use the graph sheet for this, and some students don't use graph sheet, they do it in the regular sheet by marking diagrams like this. So for 100, so 10, 20, 30, 40 like this. So this is 100, 20, 40, 60, 80, 100. This is 100 Newton per m square, sigma x. They mark it here. And then the other stress is sigma y, which is actually 40. So 10, 20, 30, 40. They mark it here. So this is sigma y. This is 40 Newton per m square. Okay. This is the two stresses. So that means if you take a plane like this, that plane would be experiencing a force of 100 Newton per m square. If you take a plane like this, that would be experiencing 40 Newton per m square. Well, now what would happen to the planes which are in between? Suppose if you have a plane something like this, what would be the stress in that? If you want to know that, then you need to draw what is called as a Mohr circle. So Mohr circle is drawn through a point exactly between these two values. So you now select the midpoint of the value between 40 and 100. Yaudu? Which one is the midpoint between 40 and 100? Huh? 70. So what you do is, you add this to sigma x plus sigma y divided by 2. So that is 70. So 50, 60, 70. You locate this point and then you draw a circle. Then you draw a circle. The circle is called as the Mohr circle. This circle actually gives you an idea of what would be the variation of the stresses in different planes in this. Okay. So this is, now imagine this plane at an angle 0 degree from the vertical. Then if it is 0 degree here, then you have to measure 0 degree here. So that means you have to measure 0 here. Suppose if you want to incline this at an angle of 15 degree here, then of course you are trying to measure the normal stress and the shear stress at an angle of 15 degree. Then you should actually increase this angle by not just 15, you should increase it by 30, which is 2 theta. So increase it by, mark an angle which is at an angle of 30. This point will give you what is the stress in the plane which is at an angle of 15 degree. If it is theta here, 15 degree, here it should be 2 theta. It will be in the same direction. Guys, it will be in the same direction. If you rotate it like this, here also you should rotate in the same direction. If you are rotating in this direction, here also you should rotate in the same direction. Okay. So in this plane, what will be the stresses? What will be the normal stress? What will be the shear stress at a plane which is at an angle of 15 degree? If you want to know, then what you should do is, then you should draw a perpendicular like this, and then you should know this distance here. So that would be the value of the normal stress at an angle of 15 degree. So sigma n at theta is equal to 15 degree is so much. And if you want the shear stress at an angle of 15 degree, then what you should do? Now I measured this in the x-axis. I should measure shear stress in the y-axis. What I should do? I should actually draw a horizontal line like this. Where this horizontal line meets the y-axis, this value gives the shear stress tau at an angle theta equal to 15 degree. Okay. So in this way, you have to find out the normal stress and the shear stress at various angles theta. What I said will match for any angle. Instead of 15 degree, if it is 30 degree, then what will be the angle here? 60. And when do you think this point will reach the maximum here? At what angle, at what inclination of theta will this reach this maximum point, maximum shear stress? 45 degree. So that means at an angle of 45 degree, you will see that the shear stress becomes maximum. Again it starts decreasing. So in a material, if a material is weak in shear, then if you apply load, it may actually break at an angle of 45 degree. It may actually get cut at an angle of 45 degree if it is weak in shear. Okay, like this you have to find out the shear stresses. Now whatever you show, whatever you are shown graphically can be actually theoretically, analytically made as an equation like this. So if you wanted the equation for this normal stress, then normal stress at any angle theta sigma n. The normal stress at any angle theta sigma n is equal to this length, which is, what is this length? Can you say me what is this length? So what is this length basically? 70. What is this 70? How did I get 70? That is sum of sigma x plus sigma y by 2, no? Yes. And then what is this length? What is this length? That is radius. Now this radius is nothing but sigma x minus sigma y divided by 2. So plus sigma x minus sigma y divided by 2 gives the radius. But you want the horizontal component of that radius. That horizontal component of the radius, this is equal to sigma x minus sigma y divided by 2 into cos 2 theta. Cos 2 theta, because this is 2 theta. So this length is sigma x plus sigma y by 2. This is sigma x minus sigma y by 2 into cos 2 theta. So here, without using this graphical method, the Mohr circle method, you can directly use this equation. Find out the normal stress by using this equation. If you don't want to use this equation, if you want to use Mohr circle, then you have to draw this diagram. Locate sigma x, sigma y, locate the midpoint, draw a circle. Then for whatever the angle you want to incline here, in the same direction, you draw a radius which is 2 times the angle, and then locate that point. Then see the horizontal distance, which is sigma, and see the vertical distance, which is tau. Okay, you got the equation for sigma n. What is the equation for tau? How do you find tau by using equation? You wanted this tau. So can somebody give me how to find tau without using the diagram? Can you tell me? Guys, what is this side? Basically, what is this side in terms of radius? Horizontal component of radius was sigma x minus sigma y by 2 into cos 2 theta, which was this distance. What is this component? Sin 2 theta. So this tau is nothing but sigma x minus sigma y divided by 2 into sin 2 theta. So instead of trying to remember equations as it is always better to correlate this Mohr circle and these equations. Otherwise, these equations looks very difficult to remember, and even in the examination, even after remembering, you may actually be not sure whether you are using the right equation or not. So please always remember these equations along with this Mohr circle. So you will actually get these equations confirmed with the diagram. So in this way, you can solve any numerical where there are only two forces, x and y. Okay, is this problem done? Have you understood this? Okay. Now, usually they just don't ask you two things. So they will ask you in this diagram, in this element which has got sigma x and sigma y which is equal to 140. What is the stress? Now, what is the normal stress and shear stress at an angle of 15 degree is one part. And they will also ask what is the maximum normal stress and what is the maximum shear stress. How do you find the maximum normal stress and the maximum shear stress? Where is the maximum normal stress in this? Now, what is the maximum normal stress in this material? Which is the which is the point on the circle which has got the maximum value of sigma? Is it this value which has got maximum value of sigma? Sigma, not tau. Of course, somebody said this has got maximum. This is true for tau. This is true for tau. And maximum value is this. And this is called as principal stress. We call it as sigma 1. Everybody uses this term. No use. I think you should not use anything like sigma p or something. Sigma 1. Sigma 1 refers to the principal stress, maximum principal stress, which is the maximum value of the principal stress in this body. Of course, because of 100 Newton per m square in this plane, at 0 degree of inclination, you will definitely feel 100 Newton per m square. Okay? And again, minimum principal stress. Minimum principal stress, if you move the points along the circumference, here you again come back here, and here you get a value which is the lowest. So that means instead of taking this plane, if you are taking this plane, then this plane is being separated by a force of 40 Newton per m square, like this. So that is referring to this sigma 2. So sigma 1 is how much? 100 Newton per m square, and sigma 2 is 40 Newton per m square. Usually, you try to make these 4 points clear, and not just on the diagram. You should also mention sigma 1 as 100 Newton per m square, and sigma 2 here I should have written as 2 theta, and sigma 2 as 40 Newton per m square. Of course, you know that here this is constant, it's not varying with respect to theta. Here this maximum value of cos 2 theta can be 1. If you make this as 1, then what is remaining? This sigma x plus sigma y by 2, which is actually this value, plus sigma x minus sigma y by 2, which is the radius. So that means this plus this radius equal to sigma 1. And again, for this minus this radius equal to sigma 2. And also, they will ask you, what is the angle at which you got this? But anyway, it is already at 0 degree. No need to mention this.